Okay, so in this video, we are going to move on to solving equations with fractions. Now, I'm going to try not to talk too much on this because you should be able to see here from thinking about when we talked about solving equations systematically and coming up with this system of looking at what's being done on the left side, what's the kind of last thing we're doing to our unknown here. You now hopefully getting into the habit of spotting this and being able to solve these types of equations. So let's just get straight into it for this first example. Now, here I have h plus 15 divided by 12 gives me 2. Now, all the questions we're doing today are going to have fractions in them, but you can see that they're actually not too different from solving systematically, which we've been doing before. So, if I look here, I'm going to think, well, what was the last thing on the left-hand side that was done to my unknown thing h, my unknown pronumeral? Now, you can see this whole numerator, h plus 15, was divided by 12, and that gave me 2. So we can now try to find, well, what is h plus 15? Because we know that dividing it by 12 gives me 2. But let's use what we've been doing so far, and we can see that dividing by 12 was the very last thing we did. So how do I undo dividing by 12? Well, I can just do the opposite operation, which is timesing by 12. That's going to kill my denominator here. And if I do this to both sides, I will get what h plus 15 is. And that is going to be 12 times 2, which gives me 24. Now, from here, I want to just find, well, what number adds to 15 to give me 24? How can I find that? Well, I can subtract 15, from both sides, and this is going to give me what h was before I added 15. So 15 more than h is 24, then h then must be 15 less than 24, hence this minus. So I'm left with just h on this left-hand side, and on the right I get 24 minus 15, which gives me 9. So we've added this new element of solving equations with fractions, but we're kind of just doing the same thing, aren't we, that we've been doing when we try to solve systematically. So let's try another question, and we'll hopefully start to get the hang of solving these types of questions. Now, question 2, we are going to find 7u minus 12 divided by 9 gives me 1. And in the same way, sorry, let me just center this here. We're going to do this in the same way. This is kind of very similar to the previous question, isn't it? Because I can find what 7u minus 12 is. Because I know that when I divide it by 9, I get 1. So I can times both sides by 9 to figure out what 7u minus 12 is. Because this is going to cancel out with my dividing by 9, timesing by 9 and dividing by 9. They undo each other to just give 1. So we just get 7u minus 12 here. Now, I'm going to then get 7u minus 12, and then 1 times 9 is just 9. So it kind of makes sense that 7u minus 12 is 9, because 9 divided by 9 gives me 1. So I'm approaching this quite logically. Like what we're doing is just stripping this away using what we know about arithmetic to find what our unknown is. And now when we get to this stage, it should be by now, hopefully, very similar and very familiar to you as just solving again systematically. This is now a two-step equation. We minus 12 from 7u to give me 9. So 7u should be 12 more than 9. And then we get left with 7u on the left-hand side. And 12 more than 9 is 21. So I'm systematically doing this. I'm chipping away at this. If some of this still isn't clear, you can go back to my videos on building up these equations and starting to solve systematically. They go through this in more depth. Here, I'm just assuming that you've watched those so I can go through this at a slightly faster pace. But I get now 7 times u gives me 21. So I can find what u is by dividing 21 by 7. And then this is going to give me u. This is going to give me what u was before I times by 7. So that is going to undo that. And I'm left with u equals 21 divided by 7. That gives me 3. So let's just do one more question in a slightly different form. And hopefully we'll get a good understanding of how we can sort of do these. But you can see even when we add fractions, it's still really just doing the same things that we did when we tried to solve these systematically. We always looked at, for example, in this question, what the last thing we did to this x was, how we built up this left-hand side. And then we can look at stripping it back to my unknown pronumeral x by just doing the opposite of the last thing each time. Now, here I have that this entire term, 3x plus 2, we added 9 to it and we got 21. So my entire thing here, my 3x over 2, should be 9 less than 21. Because adding 9 to something gives me 21, that something is going to be 9 less than 21. Now, that's going to undo my plussing 9 on the left-hand side. I'm going to end up with 3x over 2 equals 21 minus 9. That gives me 12. And we can keep going from here. So looking at what the last thing that was done to my x was, well, first I timesed it by 3, and then I divided the whole numerator here, 3x, by 2. So something divided by 2 gives me 12. Now let's try to find that something. Now, 3x, I'm just going to call it a something because I don't know what it is. Something divided by 2 gives me 12. Therefore, that something should be 2 times, should be 2 times the 12. Let me say that again. Something divided by 2 gives me 12. So that something should be 2 times 12. It's always this opposite thing happening. And this is how we can slowly peel back the layers. We can reduce our equation to something really simple. That being what we end up getting for my unknown x in this case. So once I do this, I get 3x equals 12 times 2 gives me 24. Now, very last step, what multiplies by 3 to give me 24? Well, we can find that out by saying that that something should be 24 divided by 3. 3 times something gives me 24. So 24 would be, well, so my something, sorry, should be 24 divided by 3, which brings me to my x finally. We've taken all these steps and we've slowly just built to a value for my unknown pronumeral x. And that is going to be 24 divided by 3 gives me 8. So this is how we can solve equations using fractions. It's the same ideas we talked about for solving systematically. And you can see here, hopefully in all of the working, that in essence, all I'm doing is just solving systematically.